to all. Today we are discussed about ultrasonic inspection methods. Basically, there are three types of ultrasonic inspection method or testing methods. One is pulse echo system, second one transmission system, third one resonance systems. There are three types of ultrasonic testings. Among these, today we are discussed about pulse echo system. First one is pulse echo system. In this method, we can identify the flaw inside the materials or any defect inside the materials. We have to inspect the materials whether it is defect or non-defects. So this method is called as non-destructive testing methods. Non-destructive testing method. First one is the pulse echo system. In this pulse echo system, working based on the principle of the reflection of ultrasonic waves. The reflection of ultrasonic waves at the interface of the samples. At the interface of the samples. This is the principle, basic principle of this pulse echo system. Next, descriptions. In this pulse echo system, which contains, there are three major component, major part is three. One is high frequency generator, that is high frequency ultrasonic generator. Second one, cathode ray oscilloscopy, that is screen. Cathode ray oscilloscopy screen. Third one is we are using two type of probes. One is transmitted probe, another one is receiver probe. So these are all the three major component of these ultrasonic flaw detectors. Here we are using two separate probes. One is transmitted probe, another one is receiver probe. This transmitted probe, it transmits the ultrasonic waves to the specimen, and the receiver probe is used to receive the signal from transmitted from the interface of the samples. That is the role of a receiver probe. Working when the high frequency generator generate the ultrasonic waves. This high frequency generator generate the ultrasonic waves, transmit to the transmitted probe, and it produce the ultrasonic pulse. It produce ultrasonic pulse. Here these sound waves, the sound pulse, are sent into the specimen. Now they are strike on the surface of the samples. Surface of the samples and reflected back to the receiver probe, receive the receiver probe and amplified by the amplifier. Then you can see the CRO screen, that is input pulse. This is input pulse. You can see the input pulse in the left side of the CRO. Left side of the CRO. Now if the specimen is good, if there is no defect inside the materials, means the sound waves strike bottom of the specimen, and reflected back to the receiver probe. This produce a peak which is right side of the CRO screen, that is back echo pulse. If there is no defect inside the materials, means you will receive only two peaks. One is input pulse, another one is back echo pulse. That input pulse received from the surface of the samples. The source is reflected back the surface of the samples, and the another one rays is to reflect from the specimen, that is interface of the specimen, bottom of the specimen. You will get back echo pulse. Now if the material gets any defect present in the materials, means the defect is always top and bottom of the surface of the specimens. Now the ultrasonic sound pulse is strike on the defect, the reflected sound pulse from the defect area, and the receiver probe receive the signals earlier of the back echo pulse. You know that the back echo pulse, bottom of the specimen is the middle of the specimen which have some defect. So the transmitted ultrasonic waves to fall on the defect and reflected back to the receiver probe. Here you know that this defect pulse is received early of the back echo pulse. So you can see the defect echo is in between the input pulse and back echo pulse. Input pulse is received from surface of the samples and back echo pulse received from the bottom of the specimen, and the defect pulse is middle of the specimen. That's why it reach early from the back echo pulse. And by using the amplifier signal, you can see the defect pulse is in between the input pulse and back echo pulse. From this method, you can find the time interval between the transmitted and receiver signals. That is T. You can also find by using time distance scale. Next, if you know the velocity of the sound waves, means you can find the depth of the defect. By using the formula is D is equal to Vt divided by 2. Here D is the depth of the defect and V is the velocity of the source and T is the time between input pulse and back echo pulse, then divided by 2. Here by using this formula you can find the depth of the defect and you can find the shape of the defect also find. During the testing, both transmitter and receiver probe move on the surface of the samples. It can move all the directions on the surface of the samples. Then only you can receive the defect pulse. You can examine the whole samples. And you can see all the defect pulse and input pulse in the CRO. By using these pulse, you can study the depth of the defect and the shape of the defect.